So these questions are from section 5.1 that we kind of last minute added to our second unit. These are not about probability, but about ratios and proportions. So our first question, number 17, roughly 13 out of every 100 people in the United States in 2012 were African American. So 13 out of 100. So this number up here represents the number of African Americans out of a total collection of 100 people. So this is the ratio. This marketing company wants to select a group of 250 people. So they want this group to be the total number of people they have. That's the number on the bottom. Their question is, how many African Americans should they be sure to select if they want this ratio to stay the same? Well, if these ratios are the same, then we can say they're equal. And we have fraction equals fraction. This is one of these wonderful times when we are able to use cross multiplication. I'm going to put a variable here, an x, instead of just the question mark. So 13 times 250 equals 100 times x. 13 times 250, divide both sides by 100. Now, is it possible to include 32.5 people? No. We're going to need to round up and say 33. Okay, let's talk about baseball. Maybe you recognize this problem. We talked about these numbers in class. So from 1969, my phone holding apparatus here is real high tech. Let's see if we can fit the whole thing in. Okay. From 1969 to 1977, we have one situation with Major League Baseball, and then we have now. So according to this, during this era, 4 teams made it to the playoffs, while 20 did not. So if 20 did not and 4 did, that means we have 24 total. So 4 out of 24 made it to the playoffs. Now 10 make it. 20 do not. So 10 make it, 20 do not. We've got 30 total. So if we're going to choose a team, randomly choose them, not based on, their record or whatever. Every team is equally likely to be chosen and equally likely that you pick the one going to the playoffs or not. Our question is unlike this one up here where we said, well, these two ratios are equal, we're just missing a piece of information. Now we have two that we don't know if they're equal. Are they equal? Do you have the same chance of making it to the playoffs? Or is one bigger? So we talked about 2 different ways of doing this. We can use fraction arithmetic. I can somehow try to get a common denominator down here so I can compare the numerator better. if I can somehow reduce it or somehow get it to where they're fractions that I recognize, which one's bigger or smaller. That's one option. The other option is just to turn them into a decimal. 4 divided by 24 is approximately 0.17. And 10 divided by 30 is approximately 0.33. Now, quickly we can tell you are much more likely to pick the winner now than you were